Central metal atom shows the two types of valency. They are primary valency and secondary valency. Nickel in the +2 oxidation state, it loses its 2 electron, thereby it creates the empty spaces. Only the 4 ligands will be attracted towards the central metal atom, thereby it creates the tetrachloridonickelate 2+ ions. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram University College, Temple of Excellence, Mysuru. My dear students, in this session, we are going to discuss with the Unit 9, the coordination compounds. Before going to discuss with this unit, let's see the weightage of this unit. From this unit, there is no 1 mark and a 2 mark question. Directly we can expect the 3 mark question, and the question numbers are 33, 34 and 35, and totally you can expect 9 marks. Okay. Now let's see how the questions will be arises in the 3 mark question. Okay. So how we know that when it is said to be a coordination compound, it is belonging to the group 2 inorganic chemistry. And in this chapter, mainly they are going to ask for the Werner theory, and also they are going to ask to write the valence bond theory. Based upon the valence bond theory, how the hybridization in geometry and the hybridizations which is taking place, based on that also we can expect 1 question. Okay. And in addition to that, we can also expect the differences between like a homoleptic and heteroleptic complexes, and we can also expect the 1 question which will be carries 1 mark, because all the 3 questions, they cannot ask directly with the Werner theory or by giving any complexes to write the hybridization. We can also expect 2+1 type of question from this unit. Okay, we'll see with the main important question from this unit, which has been frequently asked many times. Okay, mention any 3 postulates of Werner theory of coordination compound. We all know that in the Werner theory, the main postulates is very, very important to learn, and we all know that this Werner theory will tell us about the valencies, which has been surrounded by the central metal atom. So central metal atom shows the 2 types of valency. They are primary valency and secondary valency. So if I say it is primary valency, it is ionizable and it is always satisfied by the negative ion. Whereas the secondary valency, it is a non-ionizable and it is balanced by both negative ions as well as by the neutral atoms. Okay. So like this, any 3 postulates if you write for the Werner theory, it is easy to get for the 3 marks. Okay. One is, you need to say that central metal atom which is surrounded by the 2 types of valency, that is primary and secondary. Primary valency is ionizable and it is balanced by negative ion, whereas the secondary valency is non-ionizable and it is always balanced by the neutral atom as well as with the negative ions. Next question. On the basis of valence bond theory, account for the hybridization and geometry and magnetic property of tetracyanidonickellate 2- ion complexes, and given that the Z value for the nickel is 28. So here for this complex, you need to write the hybridization, geometry and the magnetic properties of this complexes. And we know that nickel is a central metal atom surrounded by a strong ligand known as cyanidoligand. So the atomic number of nickel is 28, and the nickel, we know that it exhibits in +2 oxidation state. So how to find out the +2 oxidation state? We all know that nickel tetracyanide 2- ion it is. So if you wanted to calculate for the nickel, for cyanide it is 4 × -1, which is equal to -2, and x - 4 is equal to -2, and x is equal to 4/2, and it is nothing but a 2 only. So it is a +2 oxidation state. Okay. So nickel will exhibits in a +2 oxidation state and it has an electronic configuration of 3d8 and its hybridization will be shown below. So it has a excited state I am showing here, the argon 3d8 4s2. So okay, in 3d, that is in the d orbital, how many electrons will be there? 8 electrons you can count. 1, 2, 3, 4, 5, 6, 7, 8. Whereas in the 4s2, these 2 electrons will be get lost when it is loses its 2 electron. That is why it exhibits in a +2 oxidation state. So that is why I have showed that nickel in the +2 oxidation state, it loses its 2 electron, thereby it creates the empty spaces. This is in excited state after losing a 2 electron. So we know that this nickel will be get attracted toward the cyanide ligand, and cyanide ligand is a strong ligand. Due to this strong ligand, the pairing of unpaired electrons will be taking place. Thereby, in the 3D system, 1 electrons will be get paired up to form a 4 paired of electron by creating a 1 vacant spaces. And we all know that the nickel which has been surrounded by the 4 cyanide ligand and it has been giving rise to the 4 vacant places. So 1 is from the 3D, 1 from the 4s and 1 from the 4p. 2 from the 4p will be get occupied by the cyanide ligand. Thereby it forms a tetracyanide-nickelate 2- ion complexes. So hence it is a hybridization will be known as DsP2 hybridization. Why it is known as DsP2 hybridization? Because we want a 4 vacant spaces and it should be occupied by the what? Ligands. That is why there are 4 vacant spaces which has been created. 1 is from the D, 1 is from the 4s and 2 from the 4p, and thereby it forms a DsP2 hybridization. And later you can show that how this complex will be formed by attacking with the 4 cyanide ligand, and thereby it undergo DsP2 hybridization. Now if you look at this hybridization, and the geometry will be looks for this tetracyanide-nickelate, it is nothing but a square planar structure. Why it is square planar structure? Because the nickel which has been attracted towards a 4 cyanide ligand, hence it is tetracyanide ligand. Hence it has a square planar structure. Coming into their magnetic property, you can see that there is no unpaired electrons during the hybridization and even the ligands which has been attacked. Hence it is diamagnetic in nature due to the absence of the unpaired of electron. So in the examination you need to write the general electronic configurations of the nickel. Later you need to show that in the 3D orbital how many electrons will be there in 4s as well as in the 4p in the excited state, that is in the +2 oxidation state. After that you need to show that which type of hybridizations can be possible with the strong ligand or with the weak ligand, and later you need to say that what is the magnetic behavior and what is the structure of that complexes. For writing up to the +2 oxidation state you will get a 1 mark, and also for writing the hybridization with the magnetic property as well as with the geometry you will get a 1 mark. So totally you will get a 3 marks from this question. Next we have one more complex. Using the valence bond theory, explain the geometry of hybridization and magnetic property of hexafluorido-cobaltate 3- ion and atomic number of the cobalt which has been given, which is nothing but a 27. So first step what you need to write? You need to write the general electronic configuration of the given complex where the cobalt is a central metal atom and it has a electronic configuration of 27 and it will be written as argon 3d7 4s2. We know that here also the cobalt which has been exhibits in the +3 oxidation state, thereby it loses the 2 electron from the s orbital and 1 electron from the d orbital, thereby it exhibits in a +3 oxidation state. So here I have shown 1, 2, 3, 4, 5 and 6. Why I have shown only 6? Because it losing a 3 electron, and you can see that 4s is vacant because it losing a 3 electron and 2 from the s and 1 from the d, and thereby it creates a 4 unpaired of electron. You can see that it requires how many ligands? it is having a 6 ligand. For that, it need a 6 vacant spaces. So already in the 3D, you can see that there are 4 unpaired electrons will be there and there is no vacant spaces at all. Coming to 4s and 4p and 4d, we need 6 places. So 1, 2, 3, 4, 5 and 6 will be get hybridized and give rise to the sp3d2 hybridization. Why it is sp3? 1s, 3p and 2d. So it is sp3d2 hybridization, and after the ligands which has been attacked, you need to show with the dark light so that how the ligands which has been attracted towards the central metal atom we can easily understood. Now if you see that complexes, it is a octahedral because the 6 ligands which has been attracted towards the central metal atom cobalt, and thereby it forms a octahedral geometry. And once you see that hybridization, you can see that there is a presence of 4 unpaired electrons will be there. Hence, it is in a paramagnetic in nature because of the presence of 4 unpaired of electrons. So, hope you all understood with the writing. First step, you need to write the general electronic configuration, and when you are writing in the excited state, show that which is a maximum oxidation state for that central metal atom, how many electrons can be lost to gain that complexes, and please see that then you write that hybridization and go through with the magnetic and geometry of that complexes. Next question. On the basis of valence bond theory, account for the hybridization and geometry and magnetic behavior of tetrachlorido-nickelate 2- ion, and given that again the atomic number of the nickel is 28. Here again we know that nickel will be exhibits in a +2 oxidation state and it has 28 electron, and ground state electronic configuration shows that organ 3d8 4s2, and we know that it exhibits in a +2 oxidation state and it loses its 2 electron from the 4s shell, and thereby it creates the 8 electrons in the 3d orbital and gives rise to the 1, 2, 3, 4, 5 electron 6, 7, 8. You can see that in the d orbital I have filled only 8 electron, whereas after losing its 2 electron, it has become completely vacant. And we know that this is a weak ligand which is attracted towards the central metal atom. There is no pairing up of electrons which has been formed here because it is a weak ligand. Okay. So that it needs another 4 extra vacant places to attract it towards the central metal atom. So it will require 1s and 3p. Hence it is sp3 hybridizations will be occurs. Okay. So you can see that these are the ligands which goes and occupied with the vacant spaces, and thereby it creates the sp3 hybridization. So once the sp3 hybridizations which is over, you can clearly know that there are the presence of 2 unpaired electrons in the d orbitals will be there, and this indicates that they are paramagnetic, and also the structure will be tetrahedral because only the 4 ligands will be attracted towards the central metal atom, thereby it creates the tetrachlorido-nickelate 2+ ions. Okay, you can show the hybridization also. Next, draw the energy level diagram for the splitting of d orbitals in an octahedral crystal field. So, crystal field. This question most of the time will be asked for 3 marks, and this time they have asked for 2 marks also in your board preparatory exams. In a crystal field splitting of octahedral as well as in a tetrahedral complexes, anyone will definitely come. Okay, even though you have learnt with writing the geometry, hybridization and magnetic behavior based upon a VBT, this is the most common questions which will be frequently asked, because VBT, you know, only 4 possible complexes which has been given, only 4 if you learn, definitely 1 will come. Similarly here, writing the crystal field splitting complexes, you know, only 2 complexes will be there. One is octahedral and another one is tetrahedral, and most of the time octahedral which has been repeated for the 3 mark. We'll see how to write it. Okay. So when it is said to be octahedral, we know that the d orbitals will be consist of 5 subshells. Correct, no? So this is a metal ion where d first orbital is d square minus y square, dz square, dxy, dyz, zx plus dyz. This is a metal d orbital. When the average energy of the d orbitals will be spherical crystal field, you know, the barycenters will be created. As a result of this, the d orbitals will be split into two energy levels, and one is known as Eg and the one is known as T2g. And in the Eg, you can see that dz square and dx square minus y square will come. Whereas in the T2g level, we represent it as dxy, yz and xz. So this is a splitting of d orbital in the octahedral complexes. You need to write the d orbital. You need to show that this is a barycenter and this is a crystal field splitting off of d orbital into Eg and T2g, and you need to mention the block's name also. So what is the heteroleptic complexes? Give an example. Either they can also ask you with the homoleptic complexes. Give an example. And also they can ask you what is an ambidentate ligand or with a bidentate ligand. We know that if the centrimetal atoms are surrounded by more than one kind of ligands are said to be heteroleptic complexes. If it is said to be a homoleptic complexes, always centrimetal atoms will be surrounded by only one kind of ligands, okay, or only one kind of donor atoms. Example for this is, you can see that the tetramino cobaltate, tetramino dichlorido cobaltate plus complexes. Hope you all understood with this unit. I'll come back with the next unit. Till that, take care, be safe. Thank you.